Hi friends, welcome back. So till now we have finished the polar plot. Today we are going to start the Nyquist plot. This is the most confusing among the students. I have heard from so many students that I have a problem in Nyquist plot, how to encircle origin, how to encircle -1 plus j0 point. Don't worry. In 3 to 4 lecture, everything will be covered up, okay? And all your doubts, your confusion will be over. I hope so. So friends, in the Nyquist plot, what we have done earlier in the polar plot, the Nyquist plot in terms of, plotting, this is just double work from the polar. Means in the polar work, what we have done one part of the, let me take over here, wait a minute. See, what I'm saying is, if for some system we have drawn the polar plot, isn't it? Your system will be, let me take the system also, is s plus 1. I think for this you can easily give the answer. S equal to 1, it will start from here. S equal to 0, S equal to 1, S equal to 2, and S equal to 3. When S equal to 1 is there, so it will start from this, and this is the polar plot for the system. In terms of plot, if I'll talk about in Nyquist plot, what will be happen, just double of this will come like this. Nyquist plot is nothing but just a double of it. Means I'll add the mirror image of the polar plot also. So this will become the Nyquist plot. But the study is not over. The Nyquist plot is somehow very different thing. Okay, here this analysis actually the right plane analysis, So let me start, then you will understand about the Nyquist plot. What is the purpose? First, let me discover this. To draw the complete frequency response of the open loop transfer function. So in the polar plot, we did not do the complete frequency response, the half part of it. In this, what we'll assume, we'll consider 0 plus and 0 minus also, both. Okay, infinity also, plus infinity and minus infinity will consider. Let me take like this. It's plus infinity minus infinity, means overall frequency response will complete in the Nyquist, means omega will vary from minus infinity to infinity, isn't it? So this is the analysis part of the Nyquist plot. Though we know about that frequency can't be negative. But to draw the complete frequency response, we need this. Okay. Second point is to find the number of closed loop poles in the right of S-plane. Very important point. This is the base point of the Nyquist plot, or I can say the foundation. See, till now what we have done, or the system stability. Let me clear some part. Wait a minute. If this is your S-plane, and if you are studying your system, suppose your system is given S plus 1, what you will see, you will check the poles and zeros of the system. Which system? Open loop transfer function, and you will plot the poles and zeros in the S-plane, isn't it? Like for this case, -1, only single pole you have. Now based on analysis in S-plane, can we conclude the system is stable or not stable? Yes, we can conclude, because we have seen if poles and zeros are coming into the LHS, then system will be 100% stable system, isn't it? Till now what we have done? We have done this only. And if your poles and zeros, anything will be there in the RHS, your system will become unstable system, isn't it? So till now we were dealing with this only. Means if you have this assurance that all your poles are in LHS, so you were saying very confidently that your system is stable system. Are you getting? what you were doing till now, if you are getting your poles and zeros only in the LHS of the S-plane, so your system was 100% stable. But in the Nyquist, according to the Nyquist, what is going on? The Nyquist criteria is discussing or analyzing this plane, the right hand plane, complete right hand plane. It's kind of at the imaginary axis. On this imaginary axis, one fellow is seated, that is Nyquist itself. ये Nyquist यहाँ पे बैठा हुआ है, and what he is doing, right plane में वो बैटरी लगा के, टॉर्च लगा के देख रहा है कोई बंदा तो ये नहीं है यहाँ पे. He is analyzing with this torch that is anybody there in the RHS plane in this area. He is checking everywhere. If someone is here and he is finding someone, so definitely he is saying that system is unstable. Simple. This is all about the Nyquist. Nyquist, what the Nyquist is doing, he is seated over here, he is not looking this side, he is looking into the RHS plane. RHS of the S plane, if he is finding anybody over here, he is just concluding, yes, system is unstable system. System is unstable system. So this is about the Nyquist. But if you talk about the root locus or Bode plot or RH criteria, this all what they are doing, they are looking this side. They are looking this side in the LHS plane and concluding the stability. So all these remaining are the LHS analysis tools, but the Nyquist is RHS analysis tool. I hope it's clear to you. Let's come to the next one. Range of K value for the closed loop stability. Definitely in all we have seen from the RH onwards, RH criteria onwards, in the root locus, Bode plot, everywhere we have seen the dependency of the system over the value K. Yes. So here also we can find out the range of K value for the closed loop stability. The next point is to find the relative stability. So this concept also, the relative stability concept also, we were studying from the RH criteria only, isn't it? So it will be continue till Nyquist plot. The next point is the very important point. Let me clear some part over here. The Nyquist plot is developed by using a mathematical principle known as the Cauchy's principle of arguments. Principle of arguments. This is the foundation point of the, the Nyquist plot. There is a mapping method. The mapping analysis based on this principle of argument is coming into the picture. So this is the GATE lectures. I'm not going deep inside of the mapping theorem and mapping analysis and all. Directly I'll come with the outcomes of that. Okay, and you have to, you try to learn the outcome of that. Very easy. Everything is easy. Okay. So the principle of argument, what is this? The principle of argument says but before that let me discuss about the mapping. What mapping says, friends, if you have two planes, one is S plane, let's take it S plane, and in S plane suppose you have some poles and zeros inside of it. Okay, now what you are doing, you are shifting the location of some points in that system S plane into some another system or another plane. Let's take it W plane. Let's take it W plane. So you are, first you are finding the relation in between these two, and based on that relation, suppose one point is given over here, you are plotting this point or mapping this point into the W plane. Okay, for example, I'll show you. Suppose your GHS is S plus 2 is plus 1 given over here. Now this is point I'm choosing, and that point is let's take it -1 plus j0. Okay, so let's put this over here, -1 plus j plus 2 -1 plus j plus 1. What you will get? You will get 1 plus j divided by j, isn't it? So finally you get 1 minus j. So when you are putting 1 plus j, you are getting 1 minus j. Now this 1 minus j, you are not looking into this plane. For this 1 minus j, you are creating some another plane in that its own origin is there, whatever you are assuming, and you are just taking 1 minus j, isn't it? So if S plane we are talking about, the point was -1 plus j, but when you put this into the given system, you got something else, and that something else you are plotting in another plane. The origin of this you are choosing like this, so you are getting the same point over here. So what is going on? You are just mapping this. This point is mapped now into this plane. This is nothing but the mapping. This particular point -1 plus j, you are mapping into this plane. Okay, so there is a shifting in origin, right? Here the origin for this system is this, isn't it? But here the origin is shifted. So this is the matter of all shifting of origin in the planes, isn't it? So this is the, I am not going inside of the mapping, okay? It will take the whole lecture to understand. Now I'll come to the outcome of this. What is the outcome? What is the principle of argument says? The principle of arguments now says, see, if the P are the poles and Z are the zeros enclosed by the random selected closed path in the S plane. Let me take the S plane. I'm checking pole and 1 0. So this is the S plane, and this is arbitrary plane W, or let's take GHS. I'm taking over here GHS one plane. So this is the will map right over here. Okay, so what the principle of argument says, if P are the poles and Z are the zeros enclosed by the random selected closed path, this is the random selected closed path I'm choosing into the S plane only. So in the S plane, then the corresponding GHS plane be encircle the origin by P minus Z times. P minus Z times. What it means? Means the same thing if you will map into this random selected path. If you will plot into the GH plane, or you will map into the GH plane, it will encircle the origin or not. It is given by P minus Z. N equal to P minus Z, where N is the number of encirclement. What it means, if you have number of poles and zeros both are equal, means you do not have any encirclement. This type of situation, you will get this type of encirclement. It may have anywhere, here, here, anywhere, but it will not encircle the origin, not at all. It will do if suppose instead of this, now you have like this. This is your S plane and this is your another plane. In this plane, you can see if poles are 2, zeros are 1. Now if you map this diagram into the GHS plane, it will encircle the origin by one time only. Okay, later I'll discuss about this direction and all. Just understand now the encirclement first. If you are mapping some points or some this random selected path from S to another plane, the encirclement of the origin is given by the principle of argument, isn't it? So, and this is given by n equal to p minus z. Now let's come to the point, and that is, the points are, if poles means p is enclosed, then there is a change in direction while mapping. If z is enclosed, then there is no change in the direction. What is this change in direction? And what is this? The p enclosed. See now. Okay. See this carefully. This is the S-plane. In the S-plane, suppose one pole is enclosed like this at -2. And the direction of this random selected plot is clockwise. This is the direction. Okay. Now tell me one thing. The encirclement in the next plane, that is GHS plane, will be there or not first? Let's find out the encirclement. N equal to p minus z. Z is 0. Yes, you have the p one time. So one time encirclement will be there. So let's make another random selected path, and one time encirclement of the origin I have done over here. Now the direction of this, initially the direction was clockwise. Now what will be the direction of this path? Now the question is, if the p is enclosed, means pole is enclosed. Yes, you can see the enclosement of poles. So you will change the direction. There is a change in direction while mapping. Yes, you are doing this. What you are doing? All this. You are doing mapping. Correct. So you will change the direction. You will change the direction. Initially it was clockwise. Now it will be counterclockwise. Okay. And mathematically, anti-clockwise encirclement I'll represent by positive sign, and clockwise is negative. Means for this system, if I'll check this encirclement, so n is nothing but -1, though this is the clockwise, and over here n is +1 because this is the anti-clockwise. So the things are the change in direction, what are the things? The change in direction and encirclement notation, isn't it? So the change in direction will be there when p is enclosed. No change in direction when z is enclosed. Encirclement notation, you will take plus. If anti-clock, you will take minus. If clock. This is all about the mapping. Okay, you have to remember all these things. So this is not important for the GATE exam, and not this principle of argument. What we'll get in the GATE examination, don't worry about that. I'll explain each and everything. Now this is the foundation of the Nyquist plot. Now we'll switch to the next thing, that is the principle of argument is total of a right plane analysis. So today's lecture will finish with this note point, and the point is the principle of argument is applied. Principle of argument is applied to the right plane by selecting the closed path. Everything is of right plane analysis. The selected total right of S-plane is called the Nyquist counter. Okay. So for the today's class it's enough. We'll meet in the next class with some more things in the Nyquist plot. Okay friends. So please don't forget to like, subscribe, and the new students, for the new updates, please subscribe to Gatematic, and you can find us on the Facebook for the doubt solving. We'll meet in the next lecture. Till then, take care and bye.